recording to Google. This thing is a paid version. Now we are asked to draw the display formula of C2H4. You know there are different types of formula. There's empirical formula, the one we saw now. That is molecular formula, which is the actual formula of a molecule. And there is also structural formula. And there is displayed formula. And yeah, these are the common for them. There is also skeletal formula, which I'm not sure whether it is needed. Yeah, so we are familiar with empirical formula, right?
Yes, sir.
And then we are familiar with molecular formula as well. But when we say
Ye-
structural formula, this one just tells us about atom bonded to each other, just to bond to another atom. Okay, if you look at this is C2H4. Look at C2H4. We know that this is which compound is C2H4 before we go. C2H4 is what? What is the name of this a compound that has this formula?
I think it's already on the screen.
You say you cannot see my screen?
I said, isn't that a thing that's already on the screen?
Ethane, right?
Yes, sir. Like it's already written.
Oh yeah, it's written there. Okay. Yeah. Oh yeah, that's true. So if it is written, so that's fine. So what I'm going is this. We know that it is C2H4, but how do the atoms? How do they bond together? We have two carbon atoms bonded, double bond to another, double bond to each other, and that is two hydrogen atoms on each carbon, and that's why we have C2H4, right?
Yes, sir.
So we can do it this way. Have you ever seen something like this? C2 double bond C2 like this. If you've seen anything like this is the structural formula. Understand me, right?
No.
Okay, so
Yes, sir.
that is the structural formula, and the one beside it here, this. If I ask you, what is the difference between both of them? What do you see as the difference between both of them?
The first one has the bond for the H displayed. The second one
So
is
you will say
different.
this one shows or displays all the bonds, right?
Yes.
Yeah, thank you. And that is why they call it displayed formula. So it displays all the bonds. So can you give me the formula of ethanol? Ethanol is C what?
Huh?
Ethanol.
Ethanol.
Yeah. What is the molecular formula for ethanol?
C-H.
C2H4.
Abby?
The molecular formula is going to be C2H5OH. This is ethanol. Okay. I think, okay, no problem. We're just building, no problem. So this is ethanol. Why this one, we don't need to memorize it. You will know it as we go very soon. So this, we don't, but I only bring it now because I wanted to just to bring out a point from it. So this is the molecular formula, right?
Yes, sir.
No.
Okay. Sebi Sumaya, sorry. Sebi, Amijila wa Abi?
Nam.
Okay.
Yes,
Now,
sir.
okay. So this one can, if you want to show, if you want to see how this bonds together, it is actually it's also the C2H6O. This is the same thing. This is also the empirical formula because this is C2H6O, right? We cannot go further down. So it's also the empirical formula, right?
Yes,
Nam.
sir.
Yes.
So now, if we want to talk about the structural formula, it means we look at how they bond together, as in we show we show how the bonds. So we have two carbon atoms, carbon bonds to carbon, the second carbon bond to OH, and then we have hydrogen, and then the three hydrogen atoms here. You don't need to disturb yourself if you don't get what I'm trying to do, but yeah, so the first carbon is bonded to three carbon atoms, three hydrogen atoms, CH3. The second one is bonded to two hydrogen atoms and OH, like this, right? Is it
Yes, sir.
correct? So this is again the structural formula. Structural, uh, structural formula. Structural formula, it shows how the atom bonds without showing the bonds. Understand me, right? Except when you have double bond or triple bond. That is when you have this, that's when it will show. Now, for display formula, we show all the bonds. So it means this OH that I write here, I have to remove the H. I have to put the bond between O and H. So this is the displayed formula, and this is the structural formula. It makes sense, right?
Yes.
Okay, so
Yes, sir.
let's forge ahead. Now, the last one, which is skeletal formula, we just mentioned it briefly. Skeletal formula will remove, you don't have hydrogen. Have you seen anything like this? Like this before, and then they call it propane.
Yeah.
This
Yes,
line.
I've seen it, but I don't know.
Yeah, this is propane. This is ethane, and this is ethane, and this is propane. So, does it make sense to you? It doesn't need to make sense. I'm just asking whether it actually makes sense. Does it make
Yes.
sense? Huh? It shouldn't make
Yeah,
sense
yes, sir.
if you
Yes,
don't know
sir.
it
Yes, sir.
before. If you don't know it before, it should not make sense. But yeah, but if it makes sense, that's fine. So you see what they do. I said let's just convert this one back to where we. I call this one ethane. I call this one propene, and then I call this one propane. So quickly, skeletal formula removed hydrogen and carbon and the bond between them. Hydrogen and carbon are not there, and bond between hydrogen and carbon also have been removed. So if you return hydrogen, if you return carbon, or how do we return carbon? Any junction is where you find a carbon. So there's a carbon here, there's a carbon here, and there is a carbon here. So if you have carbon, so if you change it on to C, and then C and C, then we attach hydrogen to them. The terminal carbon, we have three hydrogen atoms, which makes sense. The carbon in the middle, two of the bonds have been used already, so two more, we introduce them, put hydrogen. The carbon, the other terminal carbon, we have three hydrogen atoms. You will see this is propane, C3H8, C3H8. Does it make sense?
Yes, sir.
So, say sorry, I always say Sumaya. Say Sophia.
Here, sir.
Sophia, you're there. Okay, that's fine. So for ethene, we can build the thing from this single line too, right? There's a carbon here, another carbon here. 1, 2, 3. 1, 2, 3. So this is ethene. For propene, 1 carbon and carbon. 1, 2, 3. 1, 1, 2. So this is going to be C3H. There's a mistake somewhere. It's supposed to be H6. 1, 2, 3. Yeah, it's correct. H6 now. So this is C3H6. So that's skeletal formula. They remove carbon and hydrogen and the bond between them. So that's what they did. Does it make sense?
Yes, sir.
Okay, so,
Nah, yes.
okay. And there's another one that I don't know, you don't need it. That's 3D structure. You don't need that. Let's just go to where we're actually going. Now let's move to functional groups. Sorry, I want to follow JUPEB syllabus. I'm just trying to build the foundation first, but we need to follow the JUPEB syllabus. Give me one moment, please. Let me take away this. So in the JUPEB syllabus, they started with hybridization. But I don't know if we can jump there. Okay, let me just discuss functional group first. Let me see if it makes sense. Then we'll just rush. Let's rush through all those ones. So, have in mind between Ekati. If you've somewhere they be so we are going to rush through all this. So let's move to functional groups without wasting any of our time. I don't know why this is arranged in this way. I want it to display, I don't want side by side, I need only single display. Okay, yeah. So let's move to functional groups. Yeah, if they ask you to define functional group very fast, what will you say? Anybody? Abi mi nìkan ló kù níbí ni? Kọ́ lẹ́kìn mi nìkan ló kù ní kíláàsì o. Okay, yeah, we are all there. Yes. Sophia, are you there? Khadija? If you are asked
Sir?
to define, if you are asked to define what a functional group is, what's going to be your answer? What is a functional group? Quickly,
Um,
anyone, anybody can give us the definition very fast so we can move
like
forward.
like a group of atoms, like
Yes, correct. You
that
are doing
that
fine.
and that gives like characteristics.
Mm-hmm.
Yes.
You know that. That you are getting it actually. Sophia, you want to say something? Sophia is muted. I hope
I
she's.
think she's having network issues.
Yeah, I know. That's why she's having a strong network issue actually. Yeah, tó bá ti dé, we'll just reverse, as in we'll go back to re-explain. So, you tried actually. It can be a group of atom, or an atom itself can be only one atom, or a group of atoms that determine how a molecule reacts. You tell me right? So you can call it an atom or group of atoms that determine how a molecule reacts. They dictate how a molecule reacts or dictate the chemical properties of a compound any way you want it. Does that mean right?
Yes, sir.
Okay, so um, I'm just going to slow down there. But yeah, until Lebawa, maybe by. But so you could show Billy na koja tele. So, can you give me some examples of functional groups? Yeah, Sophia, trying to rejoin. Yeah, I'm here.
Yeah.
We are here, no
Um,
problem. Yeah, continue.
like propane,
Yeah, the functional group in propane. Did you say propene or propane?
propane.
Propane. Okay. Yeah.
ethene,
Are you there, Sophia?
Still breaking.
Yeah.
I cannot even see the screen yet. My screen
Subhanallah.
is still black.
Yeah, the network is so. Nigerian fee ajawagan okolon sanwani. Yeah, I'm using MTN 5G. Although 1.5G new, but it's okay to some extent. What are you using at home, Khadija? Are you using MTN or you are on
and
MTN as well?
like a Wi-Fi.
Yeah, MTN broadband. The one to one broadband to Gambi that the
I
whole
think so.
house is using.
Yes, sir. Yes,
That's
sir.
that's broadband. Yeah, but Sophia is on MiFi, I think. That is why it's
Hmm.
yeah. Okay, Sheka Malo Sheka
I think it's
continue.
better, but I still cannot see the screen. Yes. Can
Okay,
let's
you
continue.
cannot see the screen yet.
Come around. Yeah,
Huh. Let me
it's
mute.
coming around. Wait. Okay, I can see now.
Okay, Alhamdulillah. Yeah, so we're talking about functional groups. That to define what a functional group is quickly. And then we said, I think I need to write it instead of asking. So come back, Makweju. So we said they are group atom or a group of atom. We say an atom or a group of atoms that dictates sorry dictates how a compound or how an organic molecule, how a compound reacts. So that is a functional group. So for alkene, let's start with alkenes. The functional group in alkenes is carbon to carbon double bond. Are you there with me? Ṣé ń gbọ́ mi àbí? Èmi máa ń béèrè question
Yes,
so
sir.
Yes, sir.
uh-huh, ẹni tó bá ń teach online has to be asking something like that so èyí kan máa sọ̀rọ̀ lọ
Yes,
ní
that.
àrí pé àwọn èèyàn ti network ti ṣe ó ti ṣe àwọn èèyàn léṣe bó ṣe ń disturb Sumaya àbí Sophia.
Okay.
Uh-huh.
Yes, sir.
So that's why I'm just trying to confirm. So you don't say double bond, you will say carbon to carbon double bond. So for the alkynes, the functional group is carbon to carbon triple bond. And for aldehydes, they also call them alkana, alkanals. We call them that as well. So the functional group for aldehydes is, do you know that? Anybody?
Mm, I've heard of it.
Okay, so
Sir?
the functional group of aldehydes is carbon. Okay, before I move to aldehyde, don't let me give you aldehyde first. I think we are familiar. I will build it until we get to what we don't know. Okay, so alcohol first. Of course, the functional group of alcohols is what? Is OH, right? Do you know that?
Yes, sir.
So
Yes.
alcohol is OH, and then carboxylic acid is R here. Carboxylic acids. In Nigeria, we normally call them alkanoic acid. So alkanoic acid the functional group is what? Do you know that?
Mm,
I think like there's oxygen and then OH as well.
COOH. Something like this, right?
yes, sir.
COOH, yes.
COOH. Or,
My screen is lagging.
oh, sorry, they will write it this way in a compound like this. CO double bond and C single bond OH. So that is carboxylic acid. Okay, so let's move up. Now, there is ester. Esters are, in Nigeria, we call them al. Actually, I would not say in Nigeria. That is IUPAC name is alkanoids. Alkanoids. And the functional group of that is very close to that of carboxylic acid. So carboxylic acid is carbon and double bond oxygen and hydrogen. That's carboxylic acid. But if it is alkanoid, this hydrogen will run away and then it will be replaced by another alkyl group. So it can be CH3, it can be C2H5, it can be C3H7, whatever. So instead of putting that on Ashibai, they will put R here and then they put another R here. Sometimes they call this one R prime and then R, just to know that they are not necessarily same. So the R, once I put R is equal to alkyl group. Sorry, group. Now, what is an alkyl group? Before we run away from that, before we move to another functional group, can an alkyl group? With an alkyl group, you can just give me the chemical formula of the smallest alkyl
Alkyl,
group.
like
Yeah,
Y.
YL. ALKYL.
Okay.
Alkyl.
The what do you say about them? Like, what was
Yeah,
the
I
question?
was asking you, what are they? What do you know about them? Okay, can you give me the smallest?
Okay,
Uh,
they they are triple bond, like they bond to carbon with triple bond.
oh, that is
And
alkyne. The one, okay, alkyne also,
okay,
yeah.
what were you asking?
YNE.
Oh, yeah,
Yeah, that's
YLE,
alkyne. This
Abby.
one, what I'm asking is alkyl. YL. ALKYL.
I can wait. Share and are you writing on the board? Because
Oh, okay, I'm
my
writing.
screen is still on S2.
Sorry, I'm writing on the board. I wrote ALKYL. Alkyl.
ALK. Okay.
ALKYL.
Sorry,
Alkyl.
I was hearing something else.
Yeah, you are hearing alkyne. What is correct? What you said is correct. Carbon to carbon triple bond is for alkyne, YNE. But I said
Now
alkyl because I was talking about alkyl group. So you can still not, you cannot see the screen still, right?
it's breaking.
And even Khadija, are you there?
Yes, I am.
And you can see the screen, right?
Yes, perfectly.
Okay. Oh, ẹ má fi network ilé yẹn ẹ má fi ṣe bùgá fún wa o. So when you say perfectly, so ó fi jẹ́ ká máa miss ilé nìyẹn. Okay. Uh, Sophia. Sophia cannot hear us again.
I can hear.
Oh, but you cannot see the screen. Right? You can see the screen.
Sir?
You cannot see the screen, right?
I I can see.
Oh, you can see it now. And you can see what
Wait,
I'm writing. Can you
yeah.
see what I'm writing? What did I write now?
No, I cannot see what you're writing.
Ah, you can see the screen and you cannot see what I'm writing. How come?
Yes, it's lagging.
Okay, I understand. Because of the network, it's so slow. So I was talking about the alkyl group, but did you see what I wrote previously on until esters? Sorry, Yavi.
Yes, Ben.
Yeah. So about the here. So we'll build from that. Now, you think more starts money R A equals alkyl group. So and I say what is an alkyl group? It's easy. Alkyl group is just alkane. I'll give you the basic, just a basic explanation. Is an alkane, alkane minus one hydrogen atom. Alkane minus one hydrogen atom. They are not molecules. They are just we call them just a group that that make up the chain of your that make up the chain, or like a substituent group on the main chain of your organic molecule. The substituent groups, just part of the substituent groups. So an example is this. When I say alkane minus one hydrogen atom, an alkane is, can you give an example of an alkane? An alkane is CH4, which is
Methane,
methane.
propane.
So it means minus, when I say minus one hydrogen will equal to, I wanted to write CH4, I wrote CH2. So it's going to be CH3, right? If you remove one hydrogen atom from methane, it becomes CH3, and that CH3 is methyl or methyl. What's okay? Methyl. So I bring it here. You will not see it like this, because if you see it this way, it doesn't make sense. So they will put a bond like this that shows that this one bonds to something. It cannot stay on its own. It has to bond. So that's why we call it a substituent group. So this is an alkyl. So when I say alkyl group, so I will mention before we go quickly. So if I want to build or want to generate an alkyl group from from ethane, ethane is C2H6. So what will be the alkyl group for ethane? What's going to be the structure? The I'm asking anyone. It's going to be C what?
Can you please repeat the question, sir?
For methane, we said the alkyl group is methyl, and the formula is
Okay.
CH3, a bond to CH3. Now for ethane, what is going to be the formula and the name for the alkyl group that is built from ethane?
Methane.
Yeah. Ethyl. Something like this. The same thing. Methyl, ethyl. Methane, ethane. Does it make sense?
No.
Okay. And the formula is going to be a line, just like the one up there. And then we have C2, so we'll write C2 again. Because we said it's going to be, it's minus one hydrogen. Hydrogen, there are 6 of them here, so it's going to be C2H5. Does it make sense? Hello?
Yes, sir.
Look is
Yeah.
like
So it makes sense, right?
things.
So the alkyl group that I just wrote here, just with it is not part of the functional group that we were discussing because I mentioned R equals an alkyl group there. And what is that? So I will take this and reduce the size and keep it somewhere down here. So that's alkyl group. So we continue with our main discussion. We are writing functional groups. So article sorry, this is homologous series. Homologous series. And this is a functional group. Okay. Don't mind the line. I don't draw line that way. Actually, I will remove it. If I cannot draw it straight, then I will not draw it. Okay. Now, so the next that I want to look at is aldehyde now. Aldehyde. And we are familiar with it as alkanals. Let me write this better. Aldehydes. So I'm going alkanals. So what is the functional group of aldehydes? Functional group, when you see it, but you really know, compound like this, it might be okay. Alkanol is present here, or this is alkanol, or this is alkanoic acid, you know easily, or this is an ester. We'll look at example of each one of them. I think I should be adding it as we are going. So for aldehyde, the functional group is similar to ester, carbon. Are you there with me, please? Both of you?
Yes, sir.
Okay, we have the carbon. We have double bond to oxygen. We have what do you call it? We have R. R is an alkyl group. It can be CH3, remember? That's all I can here. It can be C2H5. And then here, instead of having oxygen to H, like carboxylic acid, or oxygen to another R, like ester, we will not have any of the two. We will have hydrogen there. So something like this. They normally do it this way. They call it RCHO. Which might represent the aldehyde. RCHO. R is an alkyl group. If I remove R, if I write this, if I change R to CH3, remember at the same side B, R can be CH3, which is methyl. R can be C2H5, which is ethyl. It can be C3H7. It can be C4H9. No, C4H9, yes, instead of H10. Okay. Okay, we'll come back. We'll come back to the examples. So that's aldehyde. The last one, I think we have like 3 more to look at. Oh, so we have enough space. Let me bring this down quickly. Sorry. I will. Time will never fail us.
The battery fair, like it depends on time. See,
Maybe around 11.
Okay. Okay, so let's go. Yeah, aldehyde. So we had to look at aldehyde. So let's look at aldehyde, and that is alkanone or ketone. Ketone is common name. The what do you call it? IUPAC name is Alkanone, O-N-E. I repeat, okay, is Alkanal. Alkanal,
Yes, sir.
and this one is Alkanone. So it means this formula will be very similar. So what I would do is this. So mo máa ń sábà ṣe kí ni ẹ̀, so ó máa jẹ́ kí student rántí when they are reading. So I will take this. Let's take this. In fact, let's take it together with this. And then, sorry, Ctrl Z, go take button. So let's take this, Ctrl copy V, and then I put it here. So we are going to edit this and bring this down. So I'm gonna edit it. So I'm gonna edit aldehyde to become alkano. So how do we do that? I can remove hydrogen. I was the another alkyl group. Normally put prime there. So o make pé R in one ṣe kankan náà. Wọ́n lè jẹ́ kankan náà, wọ́n lè má jẹ́ kankan náà. So that's what this prime means. So you can see just a little difference. So instead of having H here, so I want to remove this as well. Instead of RCHO, so it's going to be RCOR prime. What do you call it? Okay. Does it make sense?
Yes, sir.
Okay, so that is ketone. And amine, I have to go back to IGCSE, sorry, IGCSE Timamilara. So JUPEB, I want to see those functional group. Okay. Okay, amine, local benzene, alkene, alkyne, aldehydes, ketone, alcohol, alkyl halides is also there, arenes, and carboxylic acid. Okay, I think I fẹ́ parí functional groups. So let's go back. So we have, they said amine. So let's go to amine. Amine. Kilowatt mine with this amine. Have you heard anything about this name before or something similar to this name?
I think it has something to do with nitrogen
Yeah,
being involved.
exactly. That's it. It has something to do with nitrogen being involved. That's it. You are correct. Amine. So the functional group, as you said, nitrogen. So nǹkan tí a máa lò tá a fi rántí òun ni ẹ máa rántí ammonia àbí kí ni formula ammonia?
NH3.
Ammonia is NH3, right?
Yes, sir.
So amine. So ammonia is NH3 because of this. Because of this, nitrogen láàrin ó wá bond with 3 hydrogen atoms, right? This is not an organic compound. To become amine, which is an organic compound, one of the hydrogen will be removed, will be substituted with an alkyl group. So it's going to be R like this. R or just something, just a bond. So sometimes you will see they will just write a bond like this and then NH2 to Z NH2. The way we did up there for, okay, nothing, none of them there. In fact, you will see it for these two. What can she buy? When you fi R to be going, what can she buy? For this and this, like this. Understand me, right? It is the same
Yes, sir.
thing. Yeah. Okay. So, but it's good if you put those R there. So just a carbon chain. I'll kill you most of the time. So that is our amine. Okay, so I think there are 2 more. That is arenes. Arenes is just aromatics. arranged from aromatic hydrocarbon is what this one means. And the mama one aromatic hydrocarbon is what? Is what?
Aliphatic.
The aromatic hydrocarbon. What we know, the most popular of aromatic hydrocarbon is what? The functional group. Okay, the any popular aromatic hydrocarbon is what? Is benzene. Benzene is an aromatic hydrocarbon. So you don't know, right?
I don't know, sir.
Okay. Well, aromatic on benzene. So the name arene is from aromatic hydrocarbon. So benzene, remember benzene have a draw. I didn't draw any data. I can tell you the hexagon can be by what is the shapes here? Anyway, to embody hexagon, I will draw it myself. So we have this, this, and this. For let me draw here. What's the name? Do you know the name for this?
No, sir.
I
Ha,
can't think. I'm not
Ah,
sure.
benzene or
Mingbo?
is it benzene?
This is not benzene yet. How many carbon
Oh,
atoms do we have here? How many carbon atoms?
six. No, seven,
How many carbon atoms? Like
six.
6. It should be 6. Let me
Yes,
remove.
sir.
There's a line there. So you can remove. Camera is not 6. Because the about 7, you are correct because of this line. So, but it is 6 actually. So this. So I don't like this. Yeah. So 6. There's a carbon here, there's a carbon here, a carbon here, a carbon here, a carbon, and a carbon. A carbon
Okay.
atom will ordinarily bond to how many other atoms? How many bonds surround a carbon atom? Or what is the valency of a
4.
carbon? 4, right? So, and you can
Oh,
see the carbon
yes,
here,
sir.
they've used what the meji in our 4 bonds here, right? They've used 2, right? So Thomas meji there are 2 left for each one of them. Very fast. So those 2 left for each one of them will be bonded to hydrogen atoms. So it means this compound is going to be C6H12. Is that correct?
Yes, sir.
So this is called cyclohexane.
Group.
Cyclo because it's round, cyclic,
Yes.
cyclohexane. But that is not where we're going. We are talking about benzene. So if I remove all those carbon atoms, for this one to become benzene, it will have double bond inside. So there's a double bond here, alternating double bonds. So you see a double bond here, single bond, double bond, single bond, and then double bond. So we normally write it because those bonds, they are not separate, as in they are not isolated from each other. The bond is not stable, so they are moving around. So instead of just draw them separately that way, we normally draw them as a ring. So we draw them as ring, but this ring is staying outside. It's supposed to be inside the hexagon. So like this. So this is the functional group of arene, the basis of them, of arene. But you will see it, you won't see it as C6 because it is C6H6. C6, sorry. So please, do you agree that this is C6H6? Before we leave this part, do you agree that it is C6H6?
My screen is still lagging, so I'm not sure.
Okay. This is what I will do. Let me add one more page. So, Sophia, I'm going to work on that screen. Okay, so this is the first line, the second one, another two carbon atoms, and then we have this, and then we have the last one, Ctrl Z, and then we have a ring. Sorry, before we have a ring, so we said this is a carbon atom, another carbon atom, carbon, 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 and carbon. So if there are double bonds here, if there's a double bond here, actually, this carbon here, if I number this one as carbon number 1, carbon number 1 will bond to how many hydrogen atoms now? Remember, they bond to two carbon hydrogen atoms before when they were single bond. Now what we have is a double bond between carbon 1 and carbon 2. Carbon 1 will have how many, will bond to how many hydrogen atoms now?
Just one.
Just only one. And carbon 2, the same thing, right? Only one carbon
Yes.
hydrogen atom. The same thing for this. If I put the double bond here again, we have only one hydrogen left, one hydrogen, and then another double bond here. We have one hydrogen and one hydrogen. And if you count the hydrogen, we have 6 of them. If you count the carbon, we have 6 of them. So that's why benzene is 6,6H6, the formula. Does it make sense?
Yes, sir.
Okay. Okay. Now, you will not see it this way because this double bond, as we said, they are not stable. They move around. They alternate each other. This is not permanent here. It can be here at the moment. It can be here. It can be anywhere. So that is why they normally we use a ring to show that the double bond can be anywhere. It's not permanent in one place. Yeah. Does it make sense?
Yes, sir.
So it will be at the center like this. Now, we're talking about arranged functional groups. That's what we're talking about. So this one cannot stay on its own as a functional group. It will be bonded with something like this. Sorry. It will be bonded with something. So you will see it this way. When you see something bonded to benzene ring, so it means the compound is a ring. So this one, they will write it as, this is going to be C6H5 bond to something. Supposed to be C6H6, but the hydrogen is no longer there, right? Does it make sense?
No.
So that is why it is C6H5 bond to something. You can put R there as well, just to indicate an alkyl group. So, and then the last one is what do you call it? Alkyl halide. If I check, it's alkyl halide. Yes. You know what halides, right? What are halides? Do you know them?
No, sir.
Okay, you know what are halogens? Do you know halogens? Anybody?
Yes, halogens are group 7 or group 17.
Uh-huh. Okay. If I say chlorine, chlorine is an halogen, right? It's a halogen, right? Chlorine.
Yes.
Sir.
Okay. If I say hydrogen chloride. So it means this compound contains hydrogen and chlorine, right? Two atoms. One of them is hydrogen, the other one is chlorine. That's why we call it chloride, right? So
Yes.
if I change this from chlorine, I go back to the general name of these people. I will call them halogen, right? I will say the family name is halogen. And that is where chlorine takes its name. Are you following me, right? Chlorine,
Yes.
Yes, sir.
halogen. Now, chloride will become what? I want to name it after the family name now. It become halide. Does it make sense? Chlorine, halogen.
Yes,
Chlorine
sir.
takes the name from halogen. Chloride take the name from halides. Does it make sense? Halogen, halide, chlorine, chloride.
Yes, sir.
Okay, so now when they say alkyl halide, so it means it means it's an alkane of which the class is low. I think the class has stopped.
I'm sorry, sir.
No problem. So if I can remember where we stopped, so I think I was talking about alkyl halide. Yeah. So kiwa ni formula alkyl halide, the last what do you call it? The last functional group that I want to show. How does it look? Okay, so I think this is too small. Yeah. So to halogen is chlorine, and to chloride is halide. Now, arrange. So we're talking about alkyl halide. It's easy. Àti alkyl leni or alkyl leni. As I say, alkane minus one hydrogen atom is an alkyl. And then we now have halides beside it. This should make sense. If I write alkane down here, I write ethane down here, CH4, and then one of the four hydrogen atoms is removed. When it is removed, this one methyl, becomes methyl, and then I now replace it with chlorine, so it becomes chloroethane. But that's not what I'm doing. What I'm doing is that this one become an alkyl halide now. So this is an alkyl halide because it contains alkyl group and one halogen group, or one atom of halogen atom. So are you following me, please? Does it make sense?
Yeah.
Yes, sir.
So in that regard, how do we represent alkyl halide? It's very easy. You draw your just draw a line, and then you put let me make it big, so you can just put your carbon like this, and then a line like this, and then you have your X. So this X can be the X uh, the X can be it can be fluorine, it can be chlorine, it can be bromine, it can be iodine, right? So these are the alkenes. So sometimes if they don't call it alkyl halide, sometimes they call them halogenoalkane. Halogenoalkanes, the same name. Alkane to carry halogen group. I want to pè ní alkyl group. So does it make sense? Àti rí àwọn functional groups lórí sí. So ká tó máa lọ lálẹ́ yìí, I want to give an example of each one of them very fast for the remaining 10 minutes. Gbogbo àlà ń gbọ́ àbí àméjì là ń gbọ́?
Nah, yes, sir.
So
Yes, sir.
let's look at our one that are familiar with already. So I will just start from the alkyl halide. I will say examples. So alkyl halide, one of them is CH3Cl. This is chloromethane. Sometimes only pè methyl chloride, but the IUPAC name is chloromethane. So I can write it chloromethane. Okay, so that's a, we will see this is alkyl group CH3, and this is the chloride part of it, and then it becomes an alkyl chloride. Okay, let's go to amine. Amines is the functional group, and then aberrancy is something bond with nitrogen, and nitrogen bond with 2 hydrogen atoms. So an example of amine is that something can be CH3 again, and then we have nitrogen, and then the remaining 2 hydrogen atoms. So this one will become methyl amine. They call it methyl amine. Don't disturb yourself with the name for now. Methyl amine. Just to give an example of amine, a compound with amine functional group. So that's why I gave this methyl amine. Okay, let's go to ester, if you remember. Ester is esters. So ester is something COO or RCOR prime. That is ester, if you remember, up there. RCOO R prime. So I didn't put it in bracket. It's RCOO R prime. RCOOR prime. It can be R prime, COR, no problem. You can just alternate them. So that is ester. So the R again can be CH3, which is methyl, or it can be C2H5, which is ethyl. Now let's use CH3. Now COO. If you remember, this is R, COO, another R can be CH3, remember, which is R prime, if you remember, or it can be C2H5, another alkyl group. So let's use C2H5 this time around. So I will remove this R. So one side is CH3, the other side is C2H5. So for you to name this, we'll talk about naming as Masonic naming. But for now, this is ethyl ethanoate. This is ethyl ethanoate. It's easy. The name is not difficult. Ethyl from this C2H5. Ethanoate because we have 2 carbon atoms left. And then this is the owner of the chain. The ester is this guy, so that's why we call it ethanoate. But we'll talk about that later when we're naming organic compound. So that is esters, and then let's go to carboxylic acid. Carboxylic acids. So you are with me, right? I can see that you are
Yes,
there.
sir.
Okay, so carboxylic acid, uh, ethanoic acid, or methanoic acid. So aromatic is HCOO, sorry, something COOH. It can be RCOOH is ethanoic, is carboxylic acid. So this R, if you replace this R, it can be H. This R can be the part. This one can be H, or it can be R, which is an alkyl group. CH can be CH3, COOH. So if we say COOH, this is we have two carbon atoms, 1, 2. So it means this is ethanoic acid. Ethanoic acid. Remember, two carbon atoms is F. One carbon is meth. 3 is prop. 4 is bute. 5 is pent. Okay, carboxylic acids, aldehydes, and ketone. Aldehydes, an example of that, aldehydes. If you go back up, you will see that aldehyde is a RCHO. Kata pè nìyẹn nígbà náà, or something bound to CHO. Yeah, RCHO is aldehyde. So you just replace your R with CH3 again. So CH3, CHO. So we have two carbon atoms here. So it means it's going to be methanal. I will write this one as alkanals. So this is going to be not me because it's two carbon atom. Ethanal. So that guy is ethanol. Ketone, which is alkanone, and remember it is RC double bond O, or I will say RCO R prime, which is very easy. So we change this R to CH3, and the second R we change to CH3 as well. So I write CH3 here, which is CH3. If I want to write the structural formula, CH3, CO, CH3. Yeah, CH3, CO, CH3. So we have 3 carbon atoms here. So it means, and then we know the functional group is on. So it means the name should be propanone, from the alkanone. Propanone. Prop because we have 3 carbon atoms. And I think, yeah, for the arenes, because we know for alkene and alkane, for the arenes, actually, is benzene. I will use benzene. That's the smallest of all of them. That's, it's C6H5 bond to something. If that thing is hydrogen, so it means it's C6H6, and that is benzene. So we can just draw our benzene ring here. So this is benzene is the smallest. Yeah, it's the commonest example of a ring. So if you want us to add the remaining 2, which is alkane and alkynes, so we can have alkenes, which is CH2, double bond CH2 this time around, and that's our ethane. We are so familiar with this. And then for alkynes, so we can do the same thing. carbon to carbon triple bond. Uh, there's no e, there is no ethane, but there's propane. So there's one carbon again here. So we bond to one hydrogen, and then we have I think there's no space, so let me just write C. Let's just write the name. It's going to be so clearly imagine C double C triple bond C and then single bond. So this carbon will bond to one hydrogen atom. The carbon at the center, there's no hydrogen atom. The last carbon, there's three hydrogen atoms. So it's going to be C2, C3, C3, H what? C3H what?
C3H.
H4.
Yes, sir.
So that is propine, propine, and that ends the examples of compounds that carries those functional groups that we mentioned last time, and it also signifies the end of today's class, so we can go and sleep. So I said it's daily, so we will meet tomorrow, inshallah. Okay?
Inshallah.
Jazakallah khair. Same
Jazakallah
time?
khairan.
Yeah, welcome. Assalamu alaikum.
Is it same time, sir?
Alaikum.
Yes, the same time, inshallah.
Okay, sir. Inshallah. Jazakallah khairan.
Yeah.